Hey guys, welcome back to the Kubernetes series. So far we have deployed Nginx to Kubernetes using deployments. Also we could able to access deployed Nginx with port forwarding for debugging purposes. But how do we access it from the production environment as an end user? That's our topic for this chapter. In this chapter, we will be learning what are the Kubernetes services, what are the advantages of using Kubernetes services, and the different types of Kubernetes services with complete hands-on. So without any further delay, let's get started. We have our Nginx up and running with two replicas, meaning two pods. And when a pod is created, a new cluster private IP address is assigned to that pod. This is done by the kubeproxy agent running on the node as we discussed in the Kubernetes architecture section of this series. These pods are created in a separate network and we cannot reach these pods from outside of the cluster. Only from within the cluster we can access these pods. Let's say we want to connect a service running in a pod from another pod. We can connect to it with the IP address of the pod, but we cannot access the same service from outside of the cluster with the same IP address. Even within the cluster, we cannot rely on the IP addresses of the pod. Let us see why. As we use deployment to create these pods create and destroy dynamically, meaning if we decrease the replica count, extra pod will be deleted, and if we increase the replica count, a new pod will be created. Also, if we change the image version, all the pods get deleted and new pods get created. And whenever the pod is recreated, a new IP address is assigned to that pod. So pods are non-permanent resources and their IP address keeps on changing. And obviously when we try to access with the old IP, it fails to connect. Therefore, we cannot rely on their IPs to communicate if we want to access the services running in a pod. But it's pretty common use case where we need to access the application on the internet or from other services, especially in microservices world. Port forwarding is just for debugging purposes to access on our local machine. It's not publicly available. That's where Kubernetes services comes into picture. The main objective of the services is to abstract the pod IP address from end user. When a service is created, an IP address is assigned to that service. And this IP address doesn't change as long as the service exists. So, users can call a single stable IP address instead of calling each pod individually. And the service forwards the request to pods. Now, even if pod IP changes, it doesn't matter as the service will take care of routing to appropriate pods. These services are not created on any node unlike pods. Let us see another use case of services. Now we have two pods of same application which is Nginx. In real time, we will have many replicas of the same application. In that case, when we make a request, to which pod does our request go? Service will take care of load balancing, meaning service provides load balancing when you have pod replicas. It picks a pod randomly and forwards the request to it. So we don't need to worry about load balancing when we have multiple pods running of the same application. Services also offer other advantages like service discovery and zero downtime deployments. Now let's see services in action. Let's open our VS Code and create a new file with the name nginx-service.yaml. A service is a Kubernetes object just like our pods and deployments. Just like any other Kubernetes object, API version, kind, metadata, and spec are mandatory for services too. So as usual, we get this information with kubectl API resources grep services. As you can see, this is the services object and the short name is SVC and the API version is v1 and the kind is service. So let's fill in these fields. So API version is v1, kind is service, and in metadata we can give name as Nginx-service. We can give labels to this service just like we gave it for pods and deployments. Of course, this is not mandatory. And in the spec, we should give the ports information on which we can access this service. So for the service, ports is the mandatory attribute. And this is an array. So port 8082. So this port specifies the port number on which the service object will be receiving requests. And this is arbitrary value, meaning we can give any valid port number. Also, we should give target port, which specifies the port number of the container in the pod. This can be 80, as our Nginx is running on port 80 in the pod. So as a summary, port is the port on which service will receive the request, and the target port is the port on which the container is running. Here, our Nginx is running on 80 port in the container. There are different types of services available. Let's see them one by one with their use cases. The first one is ClusterIP Service. This type of service exposes the pods on an IP that is internal to the cluster, meaning this IP cannot be accessed outside of the cluster. This type of service is useful when you don't want to expose your application to the outside world, but all the pods inside the cluster can access it. Example, your database. Service type can be given with type attribute under the specs section. So type is ClusterIP. This is the default service, meaning if we don't give any type, it is treated as ClusterIP service. Well, now we have our service ready. But wait a second, we are missing something here. We discussed that service is an abstraction for the set of pods, meaning if we want to communicate with our pods, we should communicate through service instead of communicating directly with pods. But if there are hundreds of pods, how does this service know to which pods it should forward requests? You guessed it correct, using labels. Just like a Kubernetes deployment works as we discussed. In the spec section, we should give the labels with selector attribute. Here we should give the pod labels that we defined as part of the deployment. As you can see, here we gave app nginx label while creating the deployment. So let's give the same so that it matches those pods. Please note that when we have multiple labels defined as selectors, all the labels should match with the pod labels, not just one. So let's roll back this as we have only one pod label and save it, and let's apply this with kubectl apply. Let's go back to terminal, kubectl apply -f nginx -service.yaml. Enter. As you can see, nginx -service is created. Let's verify that with kubectl get services or just svc. svc is the short name for service. As you can see, nginx -service is created. Kubernetes service is the default service that we get when we create our cluster. So this is the name of the service and this is the type of the service, and as we discussed, whenever a service is created, it gets a private cluster IP address, and as this cannot be accessed externally, there is no external IP for this service. And this service can be accessible on 8082 port. And we created this just 25 seconds ago. So we discussed that this service cannot be accessed from outside of the cluster. Let's verify that with curl and the IP address of this service, which is 10.100.90.137, and the port is 8082. As you can see, it's not able to reach the service. And also we discussed that this service can be accessed from any of the pods in the cluster. Let us verify that one as well. So for that, let's get into one of the pods and try to access the service. So let's list down the pods. So these are our pods. I'm trying to get into this pod. kubectl exec-it and the pod name --sh. I'm sorry, I made a mistake. It's kubectl. Now we are within the pod. let's try to hit the same service as we did previously. As you can see, we got the response from Nginx. So ClusterIP services cannot be accessed from outside of the cluster, but those can be accessed from all the pods in the cluster. So as the name suggests, those are restricted to cluster. And this is the port number that we given on which the service will be receiving the request. And this is the IP address of the service. Also note that we can access the service not only with the IP address of the service, we can also access with the name of the service. So curl nginx-service 8082. As you can see, we still got the response with the name of the service. So we can access the ClusterIP services with cluster IP address or with the name of the service. Perfect. Let's come out of the pod. There might be cases where you want to debug your ClusterIP service and you want to access from your local machine. We can do port forwarding on services also, just like we did on pods and deployments. So kubectl port forward service / nginx-service, and let us access it on 8083, and our actual service is running on 8082. So whenever a request is received on 8083 port, it gets forwarded to the service which is running on 8082 port. Let's hit enter. And now let's go to the browser and let's try to access localhost 8083. There you go. We are able to access our Nginx through service which is running in the pod with deployments. Also, we discussed that service offers load balancing. Let us see that one as well in action. So let's go to the terminal and stop this port forwarding. Clear the screen. So to test the load balancing is working or not, we should generate some load, meaning let us try to access our Nginx continuously for 20 times. Now to access it, we should get into the pod. kubectl get pods. I'm getting into the pod because we cannot access this service from outside the cluster. So kubectl exec-it pod name and sh. We are now in the pod. Now we should access our service continuously and see if the load is getting distributed between these two pods. To automate this, I have a simple script. Here all I'm doing is I'm initializing a variable I with 1 and I'm iterating 20 times with the while loop, and inside the while loop I'm hitting our Nginx service with the curl just like we did previously, and I'm incrementing I with 1 and I'm closing the loop. Now this will hit our Nginx service 20 times. So to see whether our load is getting distributed or not, let's check the logs in other tab. Let's open another tab and monitor the pod logs. So kubectl logs pod name -f. -f is to watch the logs, to monitor the logs or to stream the logs. Enter. So now we are watching the logs of this pod. Let's do the same thing for the another pod also. New tab. kubectl logs pod name -f. Now we are watching the logs of two pods. If you can see, previously when we hit the service through browser, that request came to this pod. When we do port forwarding, load balancing doesn't work. It just selects a pod and always sends the request to that pod continuously. That's the reason we are demonstrating the load balancing from within the pod instead of through port forwarding. So now let's run this script. As you can see, we did hit our Nginx service 20 times. So let's go to the pod and we can see that here we got so many requests to this pod. Let's see this pod as well. As you can see, some of the requests came to this pod as well. So with this, we can conclude that load is being distributed between the pods. This is what load balancing is. Also, we can see what pods are associated with the service with kubectl get endpoints. Whenever a service is created, an endpoint object is also created with the same name as the service. As you can see, two pods are associated with this service. We can also check the same by describing the pod, that is kubectl describe service slash nginx-service. As you can see, these are the pods associated with this service. When a pod is added or deleted with the label that we have given on the service, these IP addresses change seamlessly. If we have multiple containers in a pod and want to expose two containers through services, we can define multiple ports in a single service. As you can see, ports is an array. For multi-port services, the name is mandatory. So now our service accepts requests on two ports as we defined here. One is on 8081 and the other one is on 8082. And one container is running on port 80 and the other one is running on port 8080. So now when we access our service on port 8082, the request goes to 80 port of the container, and when we access our service on port 8081, the request goes to 8080 port of the container. So these multi-port services are very helpful when you have the sidecar containers, just like your Prometheus exporters. Well, as the ClusterIP service is not accessible from outside of the cluster, how to expose our application to the public? That's where another type of service comes into the picture, which is NodePort Service. This type of service exposes the pod on each node at a static port called NodePort. We can access the NodePort service from outside of the cluster by requesting NodeIP: and NodePort. It means any request to our cluster on the given node port gets forwarded to the service, and internally it acts like a cluster IP and forwards the request to the appropriate ports. We specify the NodePort service with type attribute, type as NodePort, and we should give the port that should open on the node with NodePort. This restriction here, this port can range only from 30,000 to 32,767. So let's give 30,000. If we don't give this node port and we mention the type of the service as node port, Kubernetes automatically assigns a port that is not in use. Also, when we don't specify the target port, it is treated same as the port. Let's save it and run it. Clear the screen. kubectl apply -f nginx-service.yaml. Enter. Cool. The service is configured, meaning the service is modified because we are modifying the same service. Let's list down the services with kubectl get svc. And as you can see, the type of the service has been changed from ClusterIP to NodePort. And as you can see, this is the port that is open on the node, and this is the target port of the service. In the Minikube, we can get the node IP with Minikube IP and the cluster name -p local cluster. So local cluster is the name of my cluster. Enter. So this is my node IP. So let's copy it. Let's go to the browser and access it with this IP, and the port is the node port that we gave, which is 30,000. Enter. As you can see, we are able to access our Nginx with the node IP: node port, as this is NodePort Service. There is a shortcut here for this. Instead of you getting the IP address and typing in the browser, all you can do is Minikube service and service name, which is Nginx-service, and the cluster name -p local cluster. Automatically it will open for you. You don't need to get the IP address and type it manually. But there's a downside to this NodePort service. We are accessing this service with node IP, but node IP may change. Example, when you restart your node. Also, it is not secure as we are opening ports on the node. So it's not advised to use NodePort service in production. That's where another type of service comes into the picture, which is load balancer. This type of service exposes the pods externally using the cloud provider's load balancer. This acts like a cluster IP and node port internally. Load balancer is the preferred solution to expose the cluster to the wider internet. All we need to do to change this service to load balancer, just change the type to load balancer. That's it. This becomes a load balancer service now. So whenever we mention type as load balancer, Kubernetes sends a message to the cloud provider who is hosting the cluster, asking for a load balancer to set up, pointing to all external node IPs on a specific node port. If the provider doesn't support the load balancer, for example our Minikube, then nothing happens and the load balancer acts like a NodePort service. Let us try to apply and see what happens. Let's clear the screen. kubectl apply-f nginx-service.yaml. The service is configured. Now let's try to list down the services with kubectl get svc. As you can see, the type is changed to load balancer and the external IP is pending. If your cluster is running with any cloud provider, you will get an external IP here instead of pending, which can be accessed on the internet. Also, you can see we still have the node port here and also the target port here. So the load balancer internally acts like a node port and ClusterIP services. On Minikube, we can access this load balancer service with the same Minikube service. Enter. As you can see, it still acts like a NodePort service as we don't have the load balancer support on Minikube. Each cloud provider like AWS EKS, Azure Kubernetes Service, Google Kubernetes Engine, etc. has its native load balancer implementation. The cloud provider will create a load balancer which then automatically routes the request to the Kubernetes service. And from the service, the request is directed to the pods. Though this type name is load balancer, not only this service type does the load balancing. All the service types like ClusterIP, NodePort Services does the load balancing. That's all about services. I hope you thoroughly enjoyed it. My name is Pavan Elthepu and I thank you very much for watching this video. If you liked it, please share it with your friends and do not forget to subscribe to my channel to not miss any updates.